Hello and welcome to the office hours. In this episode, we're doing another lesson from NetworkLessons.com on OSPF LSAs. So it looks like we're going to find out how OSPF LSAs and LSDBs are formed and how they're flooded. All right, let's take a look. Looks like we have a flow chart here with an LSA. And the first decision it has to make is it asks, is this entry in the link state database? And if it's no, then add it to the LSDB, send an LSAC, then flood LSA, run the SPF algorithm, and calculate a new routing table. However, if it is already in the LSDB, we come to another decision where we ask, is the sequence number different? And if it's not, then we'll ignore the LSA. If it's a different sequence number, we come to another decision. Is it higher? If yes, we'll go to A. And A is this right here, where it adds it to the LSDB all the way down to end. And if the sequence number is not higher, then we'll send an LSU with newer information to the source. And then we have an end here. So I'm just going to read this out. There is no lab for this lesson. So each LSA has an aging timer, which carries the link state age field. By default, each OSPF LSA is only valid for 30 minutes. If the LSA expires, then the router that created the LSA will resend the LSA and increase the sequence number. Let's walk through the flowchart together. In this example, a new LSA is arriving at the router, and OSPF has to decide what to do with it. Step 1, if the LSA isn't already in the link state database, it will send an acknowledgement. It'll be added and it'll send an acknowledgement to its OSPF neighbor. The LSA will be flooded to all other OSPF neighbors, and we will have to run SPF to update our routing table. If the LSA is already in the LSDB and the sequence number is the same then we ignore the LSA. 3, if the LSA is already in the link state database and the sequence number is different than if the sequence number is different, then we have to take action. If the sequence number is higher, it means the information is newer, and we have to add it to our LSDB. If the sequence number is lower, it means our OSPF neighbor has an old LSA, and we should help them. In this case, we'll send a LSU, link state update, including the new LSA to our OSPF neighbor. The LSU is an envelope that carries multiple LSAs in it. It's not just the sequence number that the OSPF will look at to determine if the LSA is more recent. It will consider the LSA to be more recent if it has a higher sequence number, a higher checksum number, an age equal to the maximum age, if the link state age is much younger. What do the sequence numbers look like for OSPF LSAs? There are 4 bytes. They begin with this hexadecimal, and they go up to this hexadecimal number, but this one would actually be higher than this. So it begins with something higher. Anyway, I'll figure that out later. Every 30 minutes, each LSA will age out and be flooded. The sequence numbers will increment by 1. With 32 bits, we have a lot of sequence numbers, and every 30 minutes, it will increase. If we make it to this last sequence number of this hexadecimal number, it will wrap around and start again at the first hexadecimal sequence number. Every 30 minutes, OSPF will flood a LSA to make sure that the LSDB stays up to date. And when it does this, the sequence number will increase and OSPF will reset the max age when it receives a new LSA update. You can view the OSPF link state database on a Cisco router using the following command. Show IP OSPF database. Here is the output of the show IP OSPF database command, which shows us the LSDB. What interesting things can we see here? Each OSPF router has interfaces in an area. For each interface, it will advertise a router LSA. The link ID is the OSPF router ID. The first router LSA you see is from an OSPF router with router ID 1.1.1.1, and you can see the age just right here, sequence number, and the checksum, which are here. You can see that the LSA has been updated 2 times, right here, I believe. Since the sequence, oh wait, no, sorry, right here. Yeah, I was kind of confused as why this would be the count. So the hexadecimal number incremented 2 times. That's it for now. Looks like we're done with this lesson. I will start up another stream for the next lesson. Thanks for watching.